Hello, class. So this unit, we have worked so far on ratios and proportions. So we learned about how to set up a ratio. When two ratios are equal, we get a proportion, and we've practiced solving them. And then in the last section, we learned about triangle similarity, the last two, I guess, really. And we proved that triangles could be similar when we have two congruent angles. So angle similarity would be like this first one here, where maybe we have angle A congruent to angle W and angle B congruent to angle X. So if we have two angles that are congruent, then we have angle. And this is from the last section from 7.3. We're going to get two new ways to prove triangle similarity today. So this is similarity, not congruence, remember? So the triangles are the same size and shape, or the same shape, but one is a lot different in size than the other one. So this one is side similarity. And the way we would prove that is by showing that all of the sides are congruent. Three pairs, not congruent. They all have the same ratio. They're corresponding sides. I'm so used to saying congruent. I'm going to have to train myself before this chapter. So AB divided by WX, that ratio would be the same as BC divided by XY, would be the same as the ratio of AC to WY. And then remember, we would have to write a similarity statement with our letters for the triangles in the same corresponding order. The last one has two pairs of corresponding sides with the same ratio. So we could think AB to WX is equal to AC to WY. So to write them as a ratio, we set them up as a fraction, and then the included angle needs to be congruent. So in this case, my included angle would be angle A and angle W. So I'd have angle A congruent to angle W. And then because of that, because I have a side and then an angle and then a side, I have side angle side similarity. So all of our examples today are really just, do we have similar triangles and why? So this is what we're going to investigate. So in the first one, all they give us is three sides. There are no angles. So I have to see, is it side similarity? That's what I'm checking for. So that means I need to see, do all of my sides, all three pairs of sides, do they have the same ratio? So let's check our corresponding sides. So first we're going to look at AB and DF, and we're going to write 12/8. And maybe I want to write which one I'm doing there also. So let's write AB to DF. And that one is equal to 12/8. Let's go ahead and reduce that, divide the top and bottom by 4. And we'd get 3/2. Next, I'm going to look at the side that's BC to FE. Remember, we're doing bigger one on top. And that's going to be 15/10. Divide the top and bottom by 5. And we get 3/2 again. Remember, the other way I could do this is just to take 12 and divide by 8 on the calculator and get 1.5. So if you were really worried about fractions, you could just do decimals instead. My last one is AC to DE. And that's 18/12. Divide them both by 6. And I have 3/2. So all three of my sides have the same ratio. So this is going to be side similarity. And then I need to actually give a similarity statement. So I'm going to do this order, ABC and DFE. So triangle ABC is similar to triangle DFE. And that's because all three sets of corresponding sides have the same ratio. All right, for the second one, I can see I've got a side here, my side that's 8, and then I do have an angle that's congruent. I'm going to go ahead and comment on that. I know that angle H is congruent to angle M, and then I have a side to investigate, and I have HJ and I have MN. So I need to see if they have the same ratio. So I've got two sides, I've got the included angle. So we're going to go ahead and check HG. So HG to ML, and that's going to be 8/6. Divide them both by 2, and that's going to be 4/3. And then I also have to check the bottom side on that triangle. So HJ to MN, and that's equal to 12/8. Divide the top and bottom here by 4, and I get 3/2. So I really wanted them to be congruent, but this one just does not look congruent. In fact, I'm going back over my math again just to make sure I didn't screw it up. But 8/6, I mean, I divided both of those by 2. I did that one correctly. 12/8 divided both of them by 4. So they are not similar. So my sides do not have the same ratio. All right. Let's look at 3. It says show that the overlap triangles are similar with one of the 3 reasons. It always helps on these ones to rewrite those triangles separated. So I have a triangle here that's PQR. And then I have a bigger triangle that is PST. And so I can see that I've got some sides, right? And what's tricky is that on my little triangle, I have a 3, I have a 5, but on my big one, what do I label it? Well, I'm going to have to take this side PS, I'm going to have to add those together. That side's going to be 6. The other side, to find my whole length, I'm going to have to add, and it's 10. And then again, I have that included angle at the top. So I already have angle P is congruent to angle P. And I am keeping with my theme so far of making the most terrible triangles possible when I draw them out. And then I want to go ahead and check my ratios for my sides. So let's write PQ over PS. So PQ to PS is 3/6, which is 1/2. And then PR to PT is going to be 5/10, which is also 1/2. So this is going to be side and then angle and then side, because I have a side here and then an angle and then a side. And remember, the sides have the same ratio, the corresponding sides have the same ratio, and the angles are congruent. And I don't know why I wrote 1/10. I very clearly said 1/2. Well, I wrote 1/10, so let's go ahead and fix that up. So this is going to be, again, side angle side similarity, and then we'll make our similarity statement. Triangle QPR is similar to triangle SPT. Last one. Are either of these triangles congruent to ABC? So ABC is the one that I want to compare to. So first we're going to check DEF. First, check triangle. And to set up the ratio, a good way to do it is to take like biggest side to biggest side, smallest side to smallest side, medium side to medium side. So when I'm comparing AC, I'm going to compare it to, let's see, I went red to green, so red to green on blue, so I'm going to compare it to DF. And like I said, 12 is the biggest on this triangle, 8 is the biggest on this one. And this one's going to reduce down to 3/2. Then I'm going to look at CB to FE. And CB is 9, FE is 6. Divide by 3, divide by 3, so that's going to be 3/2 as well. And then I want to check AB to DE, and 6/4 is also equal to 3/2. So these ones are similar. So this is going to be, because we have 3 sides, this is going to be side, side, side similarity. And we would say triangle ABC is similar to, and the tricky part is figuring out what order to put them in. So if I said ABC, I'm doing, let's see, this is the blue side, and then actually no, other way, ABC. So we're doing red, and then green, and then blue, ABC. So red, then green, red, then green. So this is going to be triangle DEF. Now, we also want to check our second triangle. We also want to check GHJ. Because they could both be similar. You never know. So the biggest side on the first triangle was 12. And the second one is 14. So that's going to be 6/7. And then I want to check green to green. Well, that would be 9/10. Okay, can't reduce that, already not the same. Last one would be 6/6, which is equal to 1. So they're all close, right? This one's 1 and 1/7. That's close to 1. 9/10 is close to 1. 1 is equal to 1, but they're not going to be similar. So these are not similar. Okay. This is it for our 7-4 notes. We have 2 new kinds of similarity today, side, 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 and side, angle, side, along with angle, angle from earlier this unit. So as always, if you need help, please make sure you ask.